Okay, I guess that video was getting kind of long and cut us off. I think we got around to enough that realizing that most of what we do is we mark plumb here. Now, the only reason I would mark here is because what this does is this records 1 unit of 12 inches over, or this hypotenuse measurement. Now, I marked here and I marked here, and guess what? I should be able to get 12.65 as a measurement when I measure horizontally along here. Now, 0.65, you'd have to do a little calculation and turn that into 16th measurement so you can measure it on a fractional scale, but that is that. Okay, now, Deborah, I didn't realize that last movie was almost 18 minutes, so I best hurry up myself here. So, marking pitch. On our sawhorse that we were going to make, everything was a 312. So we would get really good at marking out 312. Now, it takes a little bit of time to line up the square and mark it out. So I'm changing to 312 here now. It's a little different than the 412. Line up the 312. Now, what ends up happening is there are things called stair gauges, and they can lock onto the square right here. You just thread them on like little clamps, and then they'll stay there, and then you can easily find your 312 over and over and over and over again. Now, I'm not going to buy 100 sets of those for the school. So usually what we do is we will mark the 312 once, and then this is why I brought up earlier the sliding T-bevel, because you can easily steal that 312 measurement, whatever it is. If you notice so far, we don't even know what 312 is as an angle, as a degrees. So now I have a 312 on here, and specifically a sawhorse leg, leans like so, but also leans in like so. And so we also need to put like an angle on the edge of the material, not only the face, so across the edge and across the face. And once this was cut, we would have a compound miter cut in which the leg would be able to lean, in like this and in like this at the same time. So hence pitch becomes quite useful. Pitch is also useful because it's hard to, let's say, picture degrees. So if I say, okay, your sawhorse is going to lean at, 13 degrees. That's hard for you to picture 13 degrees, but pitch is a lot easier because you can do it as a ratio. So for example, I say that your sawhorse is at a 312. Well, you know that every 12 inches you go up, you're going to go over 3. And so you can start to picture that in your head. You say, well, my sawhorse is about 3 feet tall. So if I go up 3 units, I will also go over 3 units. And so you say, well, 3 units, so I went up 3 feet. Well, I'm also going to go over 3 times 3, so I'm going to go over 9 inches. So I go up 3 units, I go over 3 units, so I go up 3 feet, I go over 9 inches. And so it allows you to, kind of picture that, and you can say, well, Mr. Wilk, that doesn't make a very nice sawhorse. I'd rather not go over that much, and you can plan kind of from there. Now, where I'm going to leave you, because I know this is getting long, is hopefully you watched the video that I posted from YouTube, and what they showed was not very well. In fact, one of the reasons I got into this is they explained the rafter table a little bit, and they explained the brace measure table right here. So making a brace, kind of the same thing. If you're going over horizontally 51 and vertically 51, this would be the hypotenuse for a right-angled triangle. What he did kind of get wrong, this is a multiplication table, but he kind of got it wrong. This is actually a board foot measure table. And so we've talked about measuring board feet as far as hardwoods go. So hardwoods need to be bought in by the board foot. And this table takes some explanation, but that's what it's for. If we ever get back to school, I can explain the board foot measure table. The last one that he never got, and he left it he left it out in the open, is that he did not know what this table was for here. And that kind of caught me by surprise because he's an elderly fellow, much like myself. And I've used this table quite often. Now, I don't want to explain it too much because I'm going to make this your assignment, that you find out what this table is. I'll give you a couple hints. It's used with a set of wing dividers, and just forgive me a second, I didn't put any on my table. I'm just going to run and grab some. Never mind, they were here all along. Okay, so how it works is that starting from 0, you are going to use a set of wing dividers, which you guys probably know from your mathematics geometry set as a compass. But dividers can, as you see, I'm changing their measurement. They're used to step off measurements, so I can step off, say if I set this to exactly 2 inches, I could step off 2 inches and 2 inches and 2 inches in certain increments. On this square, you're going to find out that somehow you're going to use the dividers to steal a measurement from this table, and you're going to use that to make a certain object. Now, again, I'm not going to give you the answer. So you use those dividers. You use this table, which I want you to find out what it is. And I'll give you another hint, is that I've used it very recently in the construction of the gazebo project that was in our shop. Anyway, thanks for listening. Your assignment, which I'll explain later, is to find out for me what this table is used for. It has a name, and then explain how you use it with dividers and a tape measure and any other tools you would need to lay out the object in which it was intended to lay out. Thanks for listening. This is Mr. Wilk's kind of first video ever, so thanks. Toodles.